In this video, I'm going to demonstrate the use of a plotting program called Grace, or xmgrace, which is available on our cluster and which can be used to take a quick first look and indeed make decent quality plots of data generated by simulations run under GROMACS. So to launch xmgrace from the terminal window of the interactive virtual desktop, we just simply type the command name, and a window opens to a graphical user interface for Grace. This is best used at full size, so I click to open the window. The first thing we do to make a plot is to import some data under Data Import. So that opens a dialog box in which we navigate to the data that we want to plot. Here is a list of directories and subdirectories, and I need to navigate down in that list to the location of my data, which is deep within directories within directories within directories. Finally, I get to a place where the files are located, and so I can choose one of these and then choose how it is to be read in. This is a single set of data, not a time, for example, with multiple things varying with that time. So I choose it as to be loaded as single set rather than NXY. And as soon as I load it, it shows up in the plot. If I want to prepare a plot that has more than one data set, then I can just load another one at this point, and another, and finally cancel out of here. And then if I scroll down, I will find that I've plotted 3 different data sets on the plot. Now the first thing you'll notice is that the graph is a little bit large for the page, a little bit awkward to look at. So the graph needs to be resized, or I'm going to be frustrated. And there's 2 ways to do that. One is to double click and then drag the box surrounding the graph, and then click one more time, and that will change the size. The other is to change the size in a dialog box under Graph Appearance, I think it is. Let's see. So the graph location in what are called viewport coordinates are these numbers here. These specify the corners of the graph. So what are viewport coordinates? They correspond to the full size of the page in reduced units. So the page is declared to be 1 unit wide. So my graph extends with a boundary on the left of 0.15 and a boundary on the left of a little bit more than 0.25. If I change this number here, my graph will get a little wider. The other numbers, the ymin and the ymax, are in units not of 0 to 1, but 0 to whatever the aspect ratio of the paper is. So if the paper is a little bit shorter than it is wide, then the ymin and ymax won't run from 0 to 1, but from 0 to something smaller. And small y is down at the bottom. So if I change this to 0.3 instead of 0.4, the graph will extend further down the page, as you can see. So it's helpful to have the graph be on the page. Another thing you'll notice is that the legend doesn't move with the graph. It has its own location, and we'll deal with that later. So in changing a graph, once you've made it, there are various things you might like to do. For example, you might like to change the scale, or you might like to change the X and Y axis labels, or the title, or things like that, or the appearance of the different curves, or what have you. And these can be done, again, in several ways. So first of all, let's consider the scale. Over here are a set of buttons. This one here that looks like a magnifying glass allows one to zoom in on a certain part of the graph that we want to see and to expand the full region of the graph to include only those points. So for example, if I press the scale button and then highlight a region like so, then the graph is zoomed in to that region. This can be undone by pressing AS, auto scale, which brings me back to where it was before. So I will again zoom in. You see, by the way, the location of the cursor is given up here in graph coordinates if you need to know that. So zooming in, click, and then I have rescaled the graph. Another way to get access to things pertaining to each axis is to just double click on the axis, which brings up a dialog box for settings related to the axis. For example, here's the label string, G of R. Here's the scale that we just adjusted, which you see you can type in numbers instead of using this zoom method, which is very fast but not so precise. And every time you make changes like that, if you actually want to do them, you press apply, and then it does those things, leaving you in the dialog box. And if you want to change things for the x-axis, you change the choice up at the top there, like so. And when you're done with that, you can close the box. The title is part of the graph appearance, and the graph appearance is this dialog box here. So here's the title. Actually, here's the title text, so if you want to have the subtitle say something different, or indeed nothing at all, then you can change the words here to some other thing. The location of the legend box is set here, and it is determined by typing in the same set of coordinates. So what that will do is specify the upper left coordinate of the legend box. And that's a bit awkward, so you have to remember what I chose for that. 8,5 was what I chose for the X, and I think also for the top corner of the Y. So if I do 8,5, then the legend box winds up right there. If you don't want a legend box, then what you can do is turn off the legend for everything. Here we go. You cannot display the legend, and then it will just go away. In general, I prefer not putting legends on graphs where you could say in the figure caption what the different curves are. Now, if you want to change the appearance of the curves, the data itself, again, you can do that in two ways. You can either double-click on the curve, which will bring up the dialog box for set appearance, okay, or this very same dialog box can be got from plot set appearance. And one of the things you can do here is delete curves off of the graph. So for instance, if I take this and command click, then I get some choices. I can hide this, or I can actually kill the data or do other things. So for example, if I hide it, that curve will go away. That was the second curve that was added after the first one. So the curves are set 0, set 1, set 2. So the green one, which was the last one added, is set 2. I can unhide it in the same way by showing it. You see also you can do things like change the width of the line. You can change the color of the line, and so on and so forth. All those kind of formatting decisions. If the data were to be plotted with symbols, you could choose the symbol. Somewhere I should be able to choose the symbols. Symbol properties. Ah, yes. Okay. To choose a symbol for a data from the main, you choose symbol properties, which gives me a place to choose a symbol. Here, of course, it's going to make a mess because there's a huge number of data points. But if I do that, I will get a whole bunch of circles. If I don't want symbols, of course, I leave that at none. So that's how you edit the appearance of the axes and the data itself. The graph itself can be further tweaked by changing the kind of frame that it has, the thickness of the frame, and so on and so forth. But the default choices are actually fairly decent looking here. There's also a way of saving a set of choices, which is done like this. Under plot, load parameters and save parameters. If I save the parameters of this plot, it will save all of the formatting choices that pertain to this plot. And those files, judiciously edited, can serve as a set of default choices to be loaded every time you run Grace, or to be loaded at will if you want to prepare a bunch of graphs that are in some way the same. So to save a set of parameters, and you then navigate to where you want that set of parameters saved, I'll put it in my home directory as test.par, and later we'll look and see what that file looks like. Likewise, the entire project can be saved. I'll save that in my home directory as testproject.agr, which is somehow the default format for Grace files. So there are some analysis programs, quite a few actually, things that you can do to the data. You can fit it, you can do running averages, you can do histograms, and so forth. None of those are particularly applicable to this data set, so I'm going to make a new project and load a different set of data with import data to display some of those features. And so the data I'm plotting here are random forces from a simulation. And this is a multiple set of data because there's forces on two different sheets. So instead of loading this as a single set, I'll load this as nxy because it's time, force on one sheet, force on the other sheet. So there's actually two curves there. And here they both appear. And they're noisy because they fluctuate. So one of the things you might like to do would be to look at a running average of these, maybe with a very long averaging time, to see whether or not, if we took a running average, we would get something that settled down to a more constant value. So among the transformations we can make are running averages, and that's what I'm going to do here. So I'm going to take a running average in which I average over a few thousand points in order to see whether these data are looking anything like constant and whether they are shifted away from 0. So if I accept that, then I should immediately get this average of this set plotted there, and I'll do the same thing for the other one. And you see what those two running averages are. They're still quite noisy, but they're distinctly below 0, which is about all we can tell with such a short set of data. Another thing that we can do is to look at a histogram of this data. And to make a histogram, we need a graph into which the histogram can be plotted when it is made. We don't want to plot the histogram into this graph because this is a time series graph, not a histogram graph. So how do we make an empty graph into which we can dump data when it's generated? And the answer to that is under Edit, Arrange Graphs. So this is a bit awkward, but what we're going to do is we're going to make an array of graphs. We're going to make 2 rows, 1 column. In other words, one graph on top of the other. And we're going to add graphs as needed to fill the matrix, and the effect of this is going to be that we have a second graph with nothing in it. Now these graphs are not a very pretty shape, and so for printing them out, this is bad. We can regard this as just an intermediate step that gave us an extra graph into which we can do something. So we highlight this top graph, and then we go and do a data set transformation histogram, and we choose the data set we want to do the histogram of, which is one of these two time series, and then we choose the graph that we want the histogram to go to. And down here we choose the starting and stopping bin for the histogram, which we'll say is minus 500 to 500 in steps of 5, which would mean there'll be 200 bins. Then at the moment we see nothing in this graph, and the reason is because it needs to be rescaled. So I press auto scale, and there's my histogram. And you can see with your eye that the mean of this rather noisy data set is actually well to the left of 0. So having made this graph, it's now a rather ugly shape, and if I were ever to want to print these out or save them in some form, this is not the form I would want to save them in. So what I would do at this stage is I would save this data in a file for later plotting. Okay, so to do that, I use data export, and the set in this graph that I can export is this set right here, and I navigate to where I want that to go, and I'll have that be in my home directory, and I'll call it histo.dat or something, and so that will be saved in a file. And now I can just delete this graph with impunity. So from Edit, Arrange Graphs, this graph, if I command click on it, I can kill it. So now I can resize the one graph that I was working on. In the horizontal and vertical directions, back roughly the way things were. So now if I want to actually print this graph as an image that I could use someplace, I would need to first do the print setup and print to a file, and now I get to choose where I want that file to go in the usual way. I will put it in my home directory. I will call it testprint.ps. This will be a PostScript file. There are other forms in which you can save it, and this should give me a file which I can use in other applications. I can also save JPEGs and PNGs and so forth. Another useful transformation of data is to do correlations, and here is the panel for that. The correlation, for example, of a data set with itself, with a lag here, let's say up to 1,000 to see the autocorrelation. This will immediately plot, without any option, plotting the correlation on the same graph as the one that we have already, which is of course not what we want. We want to see the correlation function on its own graph. So we have to go through the same exercise of creating a second empty graph just for the purpose of transferring the correlation data to it. To make that transferal, we use Edit Set Operations, and we choose the data that we just made, which is this one, and make G1 the destination graph, and we move the data set there. And we don't see anything because this graph needs to be auto-scaled, but once it is, we see this data set in a rather unpleasant color, which we can change. Line color, which is right here. And now we can see the data. Again, we might want to save this data set for further careful plotting, and so I might from this point say data export and choose this and call it core.dat or something. and then I can delete this graph. And then once again I have to resize this one by double-clicking and dragging the corner to where it needs to go. One final set of useful operations that can be performed within Grace are fitting of data. Obviously this data is not appropriate for that, but I will open up a different set of data for that purpose. This is mean squared displacement as a function of time of different components of motion of polymers, and so this is NXY data, that is one time and multiple different entries at every time, and I can read that to a graph, and so I do here, and we see we have multiple different curves. Some of these curves I'm not interested in. This is the full diffusion, this is in the x direction, y and z, and these are cross correlations that I'm not interested in. To take those off the graph, I use the Set Appearance panel and I choose these last three that I don't want, highlight them, command click them to kill them. Now to pick off the slope of this of these curves in this intermediate region where the behavior is linear, it makes sense to use the zoom tool to highlight that portion of the graph, say roughly from here to here. And now I can do, for example, a linear fit, which is called a regression, on one or more of these data sets. So if I choose a single set here, I do a linear fit, but I have many other choices. The restriction is the region over which you're doing the fit, and here I want to do it inside the graph. So if I accept this, I will get in tiny text that you can read if you have very good vision what the graph of the linear function is, as well as that linear function superimposed on the data set. Finally, it is possible to create data sets that is corresponding to some formula within Grace. To create a data set, I use Edit Datasets, and then this panel Create New by Formula. So it gives me first the choice of what I want the x value, so to speak, to start, stop at, and how many points I want. So suppose I want it to go from 0 to 5 and to have, I don't know, 500 points. And then I need to write a formula for what the curve is supposed to be as a function of this variable called $t. I type an expression for what the function should be that the y value is to contain, so I'm just making up an expression here, e to the minus t times sine of 100t. And if I auto-scale this, then I see a decaying oscillation. So in this way you can type in formulas for some function that you want to plot, possibly against the data that you've brought in if you're trying to by hand adjust a fit. One helpful tip with regard to using Grace is that it is sometimes easier to work with the page in portrait mode than landscape mode. So what we're looking at here is really an image of a piece of letter-sized paper with the short side up. And as we've seen in earlier parts of this lecture, we often want to work with two graphs at once, and that leads to short, skinny graphs. So what actually works better is to change the paper size from landscape to portrait, and then the page goes the other way. Now this graph is temporarily badly sized, but if, for example, we go to the Edit Arrange Graphs page again and decide that we want one column of two graphs, now we wind up with two graphs, one on top of the other, of a fairly reasonable shape, so that one of them can serve as the extra graph into which we put things like histograms or correlation functions, and the other one is a decent shape for working with. And then when we get ready to print this graph or save it as an image we can use somewhere else, we can delete the graph that we used as a scratch without having to worry about resizing.